Safe to drink.
What
Water
is
free from contaminants.
water free from contaminants and
Water that is safe for human consumption is called potable water.
is called potable water. So the specifications of potable water. What we have to follow is, okay, the water should be clear, colorless and odorless, and turbidity should not exceed above 10 ppm, and hardness of water must be 125 ppm, and pH must be 7.0 to 8.5. And water should be free from heavy metals like lead, arsenic, chromium, and manganese, and also dissolved gases such as H2S and CO2. And water should be free from pathogenic microorganisms. So steps we discussed in the previous class up to disinfectation or sterilization. Just I'll repeat the 4 steps. Okay, na? So first step is screening, second step sedimentation, third step coagulation, fourth step filtration, fifth step disinfection. So we completed 4 steps. So first one is a screening. So we remove large impurities present in water, like we discussed already. What are present in water is large impurities or large floating matter like leaves or bark of wood or any paper or any plastic bottles or any plastic. So that we can remove by passing the water through large mesh screens, and we can remove large floating matter present in water. And sedimentation. So we are taking the water in a big settling tank, okay, big setting tank, and we won't disturb the water for 2 to 5 hours. So let all the suspended particles, so it will slowly settle down at the bottom of the tank, okay, due to gravity. And the clear water we will collect with the help of the pumps. So that is the second step. And third step is coagulation. This is also important step because we want to remove any colloidal particles present in water, the fine particles which are present in water, we can remove by adding coagulants. Okay, so what are the coagulants we use here is aluminum sulfate and sodium aluminate. So 2 chemicals we are using here, aluminum sulfate and sodium aluminate. So when we are adding this aluminum sulfate and sodium aluminate in water, okay, in presence of water, for example, you see here, sodium aluminate in presence of water. So what is produced in water? Aluminum hydroxide flux. Aluminum hydroxide flux. So this aluminum hydroxide flux, it will trap the impurities, it will attract the impurities present in water. What are the impurities present in water? The fine particles, for example, the negatively charged clay particles. Okay. So these flux, this will attract the negatively charged clay particles, and that converting into like a bigger flux, it will form like a bigger flux, and this bigger flux will settle down at the bottom of the tank. Okay. So after settling down at the bottom of the tank, then the clear water, okay, that we will take out with the help of the pumps. So this is about coagulation. So next is fourth step is filtration. So we have to go for filtration because to remove some of the bacteria in water or any colloidal matter remaining in water, that we can remove by using sand bed, sand filter, sand bed. So here 3 layers will be there, ma. So bottom layer is a gravels layer. We will arrange like a small stones. On the top of that, we will arrange coarse layer. Okay. So like not like a stone, so it will be like a coarse stand. Okay. So on the top of that, we will take like a very fine sand layer. So 3 layers we will arrange, and we'll pass the raw water. We will pass the water after completing coagulation process. We'll pass on the surface of the sand bed so that we can remove if any colloidal matter is there in water or some of the bacteria or microorganism, so that are removed by filtration process. Okay. So next is the 5th step. This is important. 5th step. So 5th step is disinfection. Disinfection. The process of destroying or killing the disease producing bacteria present in water is called disinfection. Okay, so that process is called disinfection. So what are the chemicals we are using? The chemicals which are using for killing the bacteria are called disinfectants. The chemicals which we are using to kill the bacteria are called disinfectants. Okay. So what are the methods means? Okay. So boiling, chlorination, and disinfection by ozone. Disinfection by ozone. So boiling means what we do here? Just we boil the water for 10 to 15 minutes. Okay, we will boil the water 10 to 15 minutes, and most of the pathogenic bacteria are killed here, and we can drink that water. Okay. Next is the chlorination. Chlorination we will discuss here. 3 points are there. Means what chemicals we are going to use here is. So first we are using bleaching powder. We are adding calcium oxychloride. Calcium oxychloride in water. Okay. So what we are getting in water immediately? So calcium oxychloride in presence of water is okay. We are getting calcium hydroxide, lime residue in water. Okay, and also chlorine. So chlorine in presence of water produces hypochlorous acid. So hypochlorous acid is a powerful disinfectant where all the germs are killed which are present in water. Okay. So here, but one disadvantage by using bleaching powder is it increases hardness in water. It increases hardness in water.
People start treating us differently
Roll
because of
number
that,
88.
then we start to act differently.
Roll number 88. You're talking.
Playing each other's sides. We can stop the scope creep of the argument. We can keep things just to the facts.
So here bleaching powder, we should not use bleaching powder because it increases the hardness in water. And excess of it means by using excess of bleaching powder also we get bad smell and bad taste. Okay. So next month, the second point in chlorination is we are going to use chloramines. So chloramines we are taking here by taking the chemicals chlorine and ammonia in 2:1 ratio. And we are getting here by using these chloramines in water, what is producing in water is hypochlorous acid. Okay, so this hypochlorous acid it will kill the bacteria present in water. So these chloramines we will use in swimming pools. So chloramines is useful for disinfecting in swimming pools. So this is the second one. Already we discussed yesterday. Okay. So next, last one is chlorination. So chlorination. So what is chlorination means? The process of applying calculated amount of chlorine to water in order to kill the pathogenic bacteria is called chlorination. Means we have to know how much exact amount of chlorine we have to add in water to kill the bacteria present in water. Because if we are adding a less quantity of chlorine, we may not kill all bacteria present in water. If we are adding excess amount of chlorine, so what happens then? We get a bad smell, bad taste, and it is toxic to human beings also. So we have to know exact amount of how much amount of chlorine we have to add in water, so that we can know by breakpoint chlorination. How to know that exact amount of chlorine we can use to kill all bacteria present in water means by breakpoint chlorination. Students, you can see here when we are adding chlorine directly in water, here also in water hypochlorous acid is produced. So that hypochlorous acid, it will kill the bacteria present in water. So calculated amount of chlorine must be added to water because chlorine after reacts with bacteria and organic impurities or ammonia, okay, remains in water as a residual chlorine, which gives bad taste, bad odor, and also it is toxic to human beings. It is toxic to human beings. So we will know by breakpoint chlorination. So students, I told you if we are adding excess amount of chlorine, we get a bad taste, bad odor. It is toxic to human beings. Okay. What is mean by excess amount of chlorine? So, for example, you are taking a 4 grams of chlorine. Okay, 4 grams of chlorine you are taking in 1 liter of water. So, when you are adding 1 gram of chlorine, 1 gram of chlorine and 2 gram of chlorine, so let all the impurities are removed by chlorine. Okay, so chlorine will oxidize with all the impurities present in water, so that are removed. When you are adding 3 grams of chlorine in 1 liter of water, so that 3 grams of chlorine, okay, here with that 3 grams of chlorine, so we can kill all the bacteria present in water, completely all the bacteria present in water, we can kill with 3 grams of chlorine. Okay, so then also we are adding extra 1 gram of chlorine, means 4 grams of chlorine. So when we are adding that to extra 1 gram of chlorine, so that the chlorine that is remaining as it is in water, because there is no bacteria present in water, all the bacteria killed with the 3 grams of chlorine only sufficient. So that extra 1 gram of chlorine is now that chlorine remaining in water, so that is called excess chlorine. So that is called residual chlorine. That is called residual chlorine. So that residual chlorine no need for us. No need for us. So if it is present excess chlorine, if you are adding 1 gram of chlorine extra, you get a bad smell. You get a bad odor, and it will be affecting health of the human beings. Okay. So to know how much exact amount of chlorine we have to use to kill all the bacteria present in water and to remove the impurities present in water, so we can know by breakpoint chlorination. See now breakpoint chlorination, I will tell you slowly, you can understand. Huh? Okay. Now see, for example, students, you are listening to me. This is important.
Yes, ma'am.
Okay. See, A grams of chlorine added oxidizes all reducing impurities present in water. For example, this A grams you take like a 1 gram or 2 grams. You see here. See, 0 milligram per liter, for example, or 0 gram per liter. So 2 milligram, 6 milligram, 10 milligram, 14 milligram. So when you are adding A grams of chlorine, what happens? It will oxidize all reducing impurities present in water. It will oxidize all reducing impurities present in water. For example, it will oxidize as like iron, manganese, and nitrate present in water. There is no chlorine remaining here. Okay. So chlorine completely it reacts with it is oxidizing with the reducing impurities present in water. So you won't observe any here. You won't see any curve here. Okay. So you can see like it is like a horizontal only. You won't see any observe any increasing curve also. You won't observe. Means here no chlorine. Okay. Here no chlorine will be there. Okay. So this diagram you see. And next one. When we are adding B grams of chlorine, for example, you are adding 2 grams of chlorine. 2 grams of chlorine or B grams of chlorine added, it forms chloramines. It forms chloramines and other chloro compounds. Other chloro compounds means here the chlorine, it reacts with the ammonia present in water. It reacts with the ammonia present in water. The chlorine, it reacts with the ammonia present in water. First, when you are adding chlorine like 1 gram, it oxidizes all impurities present in water. When you are adding 2 grams of chlorine, so that chlorine reacts with the ammonia present in chloramines. What is that means? Chlorine is there in water in the form of chloramines. So here curve is increasing. Curve is increasing. You can see that is also called combined chlorine. Okay. So curve is increased. It reaches to maximum because completely the chlorine here it reacts with ammonia present in water and form a chloramines. Okay. So now next one. When we are adding C grams of chlorine, for example, 3 grams of chlorine. C grams of chlorine added, it causes destruction of bacteria. So then what happens, students, here? You can see when you are adding 3 grams of chlorine, so this chlorine and chloramines in presence of water, it produces hypochlorous acid hypochlorous acid, and it will start to destroy the bacteria. It will destroy the bacteria. C grams of chlorine, okay, that is, you can see here, when we are adding C grams of chlorine, completely, you can see the curve is decreasing. It reaches to minima. The curve is decreases. Means nothing, what happens? Here, the chloramines and chlorine, it reacts in presence of water, forms a hypochlorous acid, and that hypochlorous acid, it is a powerful disinfectant. It will inactivate the enzymes of bacteria, and it will kill the bacteria present in water. Okay, so C grams of chlorine, at C grams of chlorine, see I wrote here, C grams of chlorine added, it causes the destruction of bacteria. Means it completely destroys the bacteria in C grams of chlorine when you are adding. Okay, so you can see in the graph very clearly, the curve is decreases. Okay, it reaches to minima because all chlorine, it is produced hypochlorous acid and destroyed bacteria also up to C grams of chlorine. So curve is decreased here. Okay, when you are adding D grams of chlorine, see here, 4 grams of chlorine, for example, D grams of chlorine, that is called residual chlorine, because already at C grams of chlorine only, 3 grams of chlorine only, all bacteria destroyed. And excess adding D grams of chlorine, that is excess only. No need for us now, chlorine in water. No need to add chlorine in water. So that D grams of chlorine is, okay, that is called residual chlorine, because chlorine is present in water. See, the curve is increased again. The curve is increased again. That means there is a residual chlorine present in water. There is a excess chlorine present in water. Okay, so D grams of chlorine is residual chlorine. If D grams of chlorine, means if you are adding excess chlorine, you get a bad taste and bad. Okay, so here what we come to know now, C grams is the break point. Means that is sufficient for us to kill the bacteria present in water. 3 grams is sufficient, for example. So C grams is the break point for the addition of chlorine to water. For the addition of chlorine to water. So C grams is the break point. Okay, for the addition of chlorine to water. So this is called break point chlorination. This is called a break point chlorination. So with the help of the graph, we'll come to know, okay, so up to which grams of chlorine we can completely destroy the bacteria present in water. So you can see I gave 2 graphs here, ma. You can understand clearly. Okay, na? So this is the break point. Okay, if you're adding excess, then it is called residual chlorine. So now, advantages of breakpoint chlorination. So by following this breakpoint chlorination, or by doing this experimental method and plotting a graph and knowing about sufficient amount of chlorine, how much amount of chlorine we need to kill the bacteria. So what is advantage of breakpoint chlorination means? It removes bad taste. Yes. Okay, how it removes bad taste? Because we know by breakpoint chlorination, we will know how much exact quantity of chlorine we can add in water. Okay, so it removes bad taste. Okay, there won't be any excess chlorine now. Okay, so it removes bad taste. Okay, and bad odor, and it will oxidize all organic impurities present in water. Organic compounds or organic impurities present in water, and it will react with ammonia present in water and other reducing impurities so present in water. Okay, and it destroys completely all disease producing bacteria. Okay, so with the help of breakpoint chlorination, we will add exact quantity of chlorine in water so that all bacteria is destroyed. Okay, in water. Okay, all the bacteria destroyed present in water by adding this exact amount of chlorine. So it destroys completely all disease producing bacteria. Now students, are you
Yes,
there?
ma'am.
Are you
Yes,
there?
ma'am.
Now I am taking 4 grams of chlorine. When you are adding 8 grams of chlorine or 1 gram of chlorine, oh, now tell me, what is the reaction in water with chlorine? You are adding 8 grams of chlorine in water.
Reduces impurities.
It oxidizes all It oxidizes all
Reducing impurities.
impurities in water. When you are adding 2 grams of chlorine, what happens? When you are adding 2 grams of chlorine, for example, when you are adding 2 grams of chlorine, what happens in water? First you have added 1 gram. Again, 1 more gram you have taken. What happens then?
Forms chloramines and
Forms chloramines. The chlorine, it reacts with ammonia present in water and forms chloramines. Okay. So then you are adding again 1 gram of chlorine. Okay. Already chloramines are there in water and chlorine is there in water. What happens then? Immediately.
causes destruction of bacteria.
It forms a hypochlorous acid. Yes or no? It produces hypochlorous acid. It will kill the bacteria present in water. At which grams of chlorine all bacteria destroyed?
3 grams of
3 grams or 3 grams of chlorine, all the bacteria destroyed. Students, again you are adding 1 gram extra you are adding. What happens? Again you are adding 1 gram of chlorine.
residual chlorine is formed.
Residual chlorine. It is called residual chlorine. What happens if you are taking like that?
Bad taste, bad odor.
What, ma?
Bad taste, ma'am, bad odor.
Bad taste, bad odor you will get.
Excess of chlorine.
Should not use excess chlorine in water. Yes or no?
Yes, ma'am.
We should not use excess chlorine in water. Okay. So with the help of breakpoint chlorination, what we can know now? What is advantage? Tell me. What is advantage with breakpoint chlorination?
We can avoid the
Taste,
water
bad
being
color, odor.
Remove
Just
bad
completely
taste,
out.
color,
Remove the
oxidation
bad
completely.
taste, bad odor or color. Okay, we can remove all impurities present in water and all bacteria present in water. Yes or no?
Yes, ma'am.
Okay, so this is about chlorination. So students, when you will get the question what is potable water and explain about treatment methods of potable water. So you have to write all the 5 steps. Understood?
Yes, ma'am.
Okay. If they will ask you only chlorination, how many steps you will write? What you will write? They will ask you only chlorination. Students, they will ask you only chlorination. Then what you will write? You write only about these 3 points. Okay, na? No need to write ozonization. Clear, everybody? No
Yes,
need to
ma'am.
write ozonization. Okay. Now, last one. This is the other method, ma, disinfection by ozone. Okay. So we are using ozone, ma. So it is a disinfectant. So when we are adding ozone in water, what is produced in water is nascent oxygen. So nascent oxygen is a powerful disinfectant. Nascent oxygen. So this is highly unstable. Okay, ma. Nascent oxygen. So this will kill the bacteria present in water. It is a powerful disinfectant. But this we are not following in industries because this is costly method, expensive. So this ozone is highly unstable. Ozone is highly unstable and it will decompose to give oxygen and nascent oxygen. Oxygen and nascent oxygen. So this nascent oxygen is a powerful disinfectant or oxidizing agent. So it will remove all organic bacteria present in water and also it will kill the bacteria present in water. Okay. So this we are not taking in municipalities because this is a costly process, expensive method. Okay. So this is about ozonization. So students, this is about treatment of potable water. Okay. So this you have to write when you get the question. So first they will ask you what is potable water definition. Then what are the specifications of potable water. Then they will ask you to write treatment methods. Okay. So then you have to write treatment methods. Okay. Chlorination and ozonization. If they will ask you only chlorination, you have to write only about chlorination. So one more topic is there for us. Okay, last topic in second module. So students understood ma this class? Students?
Yes, ma'am.
Okay, ma.
Yes, ma'am.
Only last topic is left ma for us in second module, reverse osmosis. So that will complete today only. Then we can start the third module. Okay. Students, what you are doing at home? Are you studying or just listening to the classes and leaving? Students, what you are doing at home? Just listening to the classes and leaving?
Yes, ma'am.
You are preparing,
Yes,
you are reading, you are studying every day,
Not every day.
not every
No, ma'am.
day. No, huh?
Not every day studying, ma'am.
Mid exams directly you will write, huh? Mid exams, you want to prepare, huh?
Direct attack, ma'am.
Direct attack.
When, ma'am? 10 days before preparation.
Mhm.
Ma'am, when is mid exams, ma'am?
We don't know,
Seven.
but maybe after, in the month of February only, after first week, I think.
February 7th, ma'am.
February 10th, huh?
7th,
7th, ma'am. 7th
Seventh,
to 11th.
Okay.
7th to 11th.
Okay. You got a timetable.
వచ్చింది
Yes,
ma'am.
ma'am.
అవునా?
మ్యామ్
Okay.
అంటే అది చేంజ్ అయ్యి అదేదో పోస్ట్ పోన్ చేశారని చెప్పారు మేము ఆల్ బీటెక్ అని చెప్పి టెలిగ్రామ్ లో వచ్చింది అది అది మా ఫస్ట్ ఇయర్ వాళ్ళకి కాదా?
We don't know, ma. We'll see. We don't know. Okay, ma. Last topic is desalination. Okay, desalination. So what is desalination means? This is the last topic, students. Okay, na? So desalination means the process of removal of NaCl present in water, ma. Sodium chloride. Okay, the process of removal of sodium chloride present in water, that is known as desalination. Okay, you can understand here. What is desalination means? Removal of the process of removal of dissolved salts like a sodium chloride present in water is known as desalination. Okay. The water containing high concentration of dissolved solids, with a peculiar salty or brackish taste. Okay, if you are getting a salty taste, that is called a brackish water. So what is brackish water means? We get a salty taste. If more percentage of sodium chloride present in water, that water is also known as brackish water. So seawater is the example of brackish water. It contains 3.5% of dissolved salts. 3.5% of dissolved salts. Okay. So before means we can't use seawater directly for domestic purpose or industrial purpose. So we have to remove this NaCl present in water. Then we can use that water for domestic purpose and industrial purpose. Okay. So that will go for desalination. That is the what we are taking. The method is reverse osmosis method. See the students here. So seawater, it is containing the salinity. It will be greater than 35,000 milligram per liter. The salinity is greater than 35,000 milligram per liter. If we take brackish water, the salinity will be that the range will be 1,000 to 35,000 milligram per liter. Okay, we get like a salty taste, 1,000 to 35,000 milligram per liter. And fresh water contains the salinity is, okay, means presence of sodium chloride. The salinity of water is less than 1,000 milligram per liter. Less than 1,000 milligram per liter. Okay, so brackish water and seawater not fit for drinking as well as industrial purpose. Okay, so what we do? We will go for desalination process. Students, are you there?
Yes, ma'am.
Students,
Yes, ma'am.
tell me what is desalination. They will ask you what is desalination. What you will write? What is desalination? Students, what is desalination? What is mean by desalination?
The process of removal of dissolved salt.
The process of removal of what we are removing?
NaCl.
NaCl. The process of removal of dissolved salt NaCl present in water is known as
Desalination, ma'am.
desalination. Okay. So seawater, okay, we can't use for domestic purpose or industrial purpose, see ma, if you take the ocean surrounding areas or sea areas, many villages will be there. Okay, so now till now also some villages they don't have drinking water. Yes or no? They don't have drinking water. So they can get easily drinking water by reverse osmosis process. They can establish, or they can get a plant like one reverse osmosis plant near the sea area, that area. All that village people, they will get, no? Yes or no? Yes or no?
Yes, ma'am.
Yes, ma. This is very, very good advantage. Okay, best method. This is very, very best method, reverse osmosis method, where we can remove the dissolved salt present in water, and we
Anitha
can.
Rani,
Ma'am.
Anitha Rani,
Yes,
don't
ma'am.
cut. No, don't cut. Give the host to me.
Okay, ma'am. Okay. Just
Don't.
I will leave the class, ma'am. Just I will leave the class. Okay, na?
No need to leave. Host give to me.
For the polymer, ma'am. Okay. Preparation of the polymer. Okay, students will discuss in next class, ma'am. Okay, na?
Yes, ma'am.
Okay, shall I end the class?
Yes, ma'am.
Yes, ma'am.
Okay.